Hello students, welcome back. Let us solve one more problem from Csir-Net December 2012. So here they say the ground state and first excited state. Ground state is psi naught x and the first excited state is psi 1 x, which is the multiplication of psi naught x and sine hyperbolic x. And m is equal to given half and h cut is 1, and the eigenvalues are also given for ground state and the first excited state. For ground state it is -4, and for first excited state the eigenvalue is -1, and we need to calculate the ground state wave function. So you have been given the eigenvalues, and you have been given the m. H cut is, you have to take h cut is 1, m is half, and first excited state wave function is given. Okay, so what we can do, we can use the Schrodinger equations to find out the solutions. So let us say my Schrodinger equation is minus h cut square upon 2m del 2 psi upon del x square plus vx equal to e psi x. So eigenvalues are given for both the cases, and h cut is 1, m is half, so this becomes simply minus. So my Schrodinger equation become psi dash x plus vx into e psi x. Now let us take the first case. First case, your wave function is psi naught, so this becomes psi naught double x plus Vx, and the eigenvalue is -4, and this is your psi naught x. Say this is equation number 1. So you can use this equation. And for equation 2, you have psi 1 double dash. Okay, so you have psi 1 double dash x plus Vx, and you have -1 psi 1 x. Now what we can do, we can expand this one. So this is basically del 2, minus is there also, minus is also there. So minus I can take common here, so this becomes psi 1 double x x minus Vx, and this become psi 1 x. Say this is equation number 2, and here also I can take minus common, so this become plus, this become minus, and this become plus. So this is my equation 1 and 2, and now this is equal to del 2 upon del x square. Psi 1 is your psi naught sine hyperbolic x minus Vx. You have a psi naught x or psi naught sine hyperbolic x. And now let us differentiate twice. So if you differentiate one time, you get psi naught cos hyperbolic x, then second time psi naught dash, and you get same sine hyperbolic x. You have minus Vx, and then you have a psi naught sine hyperbolic x. Differentiate one more time, will give you psi naught sine hyperbolic x. Then you will have psi naught dash cos hyperbolic x. Here, if you write psi naught, this become cos hyperbolic x, and then you will have psi naught double dash sine hyperbolic x. Then you have a minus Vx and sine hyperbolic x. So this equation simplifies and become, now you have a psi naught cos hyperbolic, psi naught psi dash cos hyperbolic, so this becomes 2. And now if you divide by sine hyperbolic x, so this equations becomes psi naught plus 2 psi naught dash cos hyperbolic x divided by sine hyperbolic x, and this becomes psi naught double dash minus Vx psi x. Okay, here Vx psi naught x also there. Here psi naught x is there, psi naught x, and here you have v psi 1 dash x also there, psi 1 dash x v1, psi 1 dash x, psi 1 dash x. Okay, so now when you are dividing by sign hyperbolic, so you have only remaining psi naught, v psi naught x. Okay, and here you have only psi naught remaining. So now what happens? This psi naught cancels, and this value is plus 4 psi naught x. Okay, so you have 4 psi naught x equal to minus 2 psi dash, that is del psi naught upon del x, and this is cos cos upon sine. Okay, cos upon sine, this is a cos upon sine, cos hyperbolic x, sine hyperbolic x. Okay, now just we have to integrate this equation. So now I'm bringing, this is psi naught, I'm making one side, so this is 2, this is minus 2, so del psi naught upon psi naught. Okay, this coming here, this going down there, so this will be minus 2 sine hyperbolic x upon cos hyperbolic x, and then you have a del x here. Now just integrate this equation, will give you the answer. So this will be ln psi naught, and this will give you, if you integrate this one, this will give you ln of cos hyperbolic x, okay, which is equal to ln of cos hyperbolic x power minus 2, and if I write this, become ln sec square hyperbolic x, and this you have a ln of psi naught, and now psi naught will be some constant a sec square hyperbolic x. If you take a constant 1, then this is simply your solution sec. So let us check the options. So you have option C is the correct answer for this question. So hope you like the solution. Thank you very much.